Now we'll look at the rules that ASME gives us about drawing sections. First of all, do not show hidden lines in section views. Now, this example that they're showing us here is a style called a half section, which we'll look at next time. It's a style where one half shows the visible outside and the other half shows the sectioned inside. But if you think about where would there have been hidden lines, you can picture that there would have been a lot of hidden lines in this part if hidden lines were allowed. But they're not allowed. We do not draw hidden lines when we have a section view. We do show center lines. So see here, see those center lines? We do show those. So hidden lines, no. Center lines, yes. If there comes a case where a hidden line in a section view is actually important for communicating some idea, then ASME says, well, then of course it's reasonable to put the line in. So here's a part with a sloping groove cut in it. In this case, it actually helps the reader to see that hidden line. So in that case, it's okay. We get to use our judgment. We want to show visible edges. So here's a pipe with some stepped holes bored in it. We want to show those edges. Here's a pillow block with some grooves. We want to show those edges. So not that one, not that one. We need to show where those edges will be. And when we cut a section, we show the edges that would be visible beyond where we made the section cut. So not just empty space, but we actually show what would be visible. Within reason. And AutoCAD, and ASME sometimes uses the one layer back sort of idea to help us think about what is reasonable. They are saying, again, use your judgment and think about what would be the most clear for the reader. Here's some kind of hand wheel with a sloped spoke. And if you showed all the spokes, that would not be helpful. That would be confusing. So they're recommending show just the one. They don't say one layer back. Those are my words. But they are recommending one layer back. Basic idea, they're recommending clarity. And you do not put hatching in the back side of holes. Here's ASME showing us that, and here's our book showing us that. Those holes are just regular object lines, and it helps if you think about the imaginary saw blade cutting through your object. Think about how the saw blade cut this solid stuff. It did not touch the back of the hole, so we would not hatch the back of the hole. And then when you have items that are parallel with the cutting plane, you do not hatch them, even though maybe the imaginary cutting plane did cut through them. So for example, here's ASME showing do not hatch the shaft. Do not hatch the key in the shaft. Do not hatch the bolt or the bolt head or the nut. And do not hatch things that are like gussets or ribs. This is a base on a light pole that used to be at the LCC campus. It's been replaced with a more modern style now, unfortunately, so we can't go look at it. But it looked like this. Well, if you made a drawing of that light pole base for someone, and you cut a section through the middle, and you said, okay, well, I sectioned through there, so I'm going to hatch there, what would the reader think? If the reader looked at that hatching, they would think, oh, looks like that's a solid cone, and that's not what you're trying to communicate. So that's why ASME says, If you have things like ribs and gussets and webs and that sort of thing, you do not hatch them, you just hatch the main body of the thing, not the ribs and gussets. So here is the ASME illustration on the top of this slide. A lug is like an ear with a hole in it that you might put a crane hook through. A gusset is basically the same thing as a rib. A gusset is a sloping flat thing that provides additional stiffness to the part. There are some illustrations on the bottom. We do not hatch spokes, so we saw an earlier example that looked similar to this picture here, where ASME did not hatch the curvy spoke, they did hatch the ring and the hub. Here on the left is an example of the difference between a solid web and a thing with spokes. So if it's a wheel or a pulley or something with spokes, ASME says do not hatch them. If it's a wheel or a pulley with a solid web inside, ASME says do hatch that, and that communicates to your reader that you are talking about a solid web and not just some spokes. Now, when you have an odd number of things, an odd number of features, you use that good old conventional revolution rule that we've seen before. Do you remember when we looked at polar dimensioning and holes on bolt circles, and we said if there were an odd number of holes, you show the side view as if there were only two of them 180 degrees apart. Well, that's what you do with a section view as well. Here is a part that has 3 holes and 3 gussets. And when you show the section view, you draw it as if there were only 2 holes 180 degrees apart and 2 gussets 180 degrees apart. And then you show the reader how many there really are by showing them the top view. ASME has this page which talks about line precedence. It might be a little confusing. If you have lines lying over the top of lines, what takes precedence over what? Well, visible lines are thicker than hidden lines, and visible lines are thicker than center lines, so obviously when you print your drawing, the visible lines are going to take precedence because they'll be visible. According to ASME, if you have a hidden line and a center line, you just show the hidden and you remove the center line. But what's especially important for you as you're drawing a section view is that the cutting plane line takes precedence over the center line. Center line is in the bottom of the priority list. And what that means for you is that if, like in this offset section you see in the bottom here, if you have a cutting plane line that lies over the top of the same place you have a center line, delete that center line. The reason is, if you leave the center line in there, its dashes and spaces will probably not line up with the cutting plane lines, dashes, and spaces, and you'll have what appears to be almost a continuous line with thick cutting plane stuff and thin center line stuff, and it's confusing. So ASME says, delete the center line out of there if you've got a cutting plane line. Now, here is the part that we'll be drawing as a full section in our assignment. And our book has given us this isometric view. These numbers are a little bit blurry. The resolution was a little bit low. Let me know if you have trouble reading any of these numbers. I tried to go in and fix them up with Photoshop, but I might have missed some, so let me know. Now, there's a radius of a 32nd of an inch, 0.03, going all the way around the outside of this flange. And that's why our book has put a circle around the elbow of that leader line. And I've showed you that leader line in a straight-on view here, not a smashed isometric view. So that is a standard all-around symbol. And you find that all-around symbol used all over the place, in dimensioning, in surface finish, in geometric tolerancing, in weld symbols. They're everywhere. And how you do it is you just draw your regular leader line, and then you put a circle centered right over the elbow of that leader line. In weld symbols, we make those circles 0.2 in diameter. In dimensioning, I think ASME does not tell us a number, so you can make it whatever size feels good to you, 1/8 to 1/4 somewhere. Now, in our book, he has used these sort of sketchy dot dash lines to indicate where a curved surface is tangent to a flat surface. He's just doing that to illustrate that those are tangents, but remember that we never draw a tangent line on our drawing, so you will not draw those on your drawing. That's just our book being pictorial. Here is what your drawing will look like. So here's the top view of the drawing with its center lines. Notice that I've connected the center line all the way through the round stuff, so it's just one continuous center line going all the way through and a vertical center line going all the way through. And the little short dashes did not land in the middle of the circles, and ASME says that's totally fine. There's a little short dash, there's a little short dash, there's a little short dash, and there's one. ASME says no problem, you just draw the line and it lands where it lands. So there's the top view. Remember our rule, which says if the section is cut along a center line, you do not need to use a cutting plane line. So yay, your section is cut along a center line, and your top view will look just like this. No cutting plane line is needed. Then here is what your full section view will look like. This is where the front view would have gone. This is the full section. Notice there are no hidden lines because that's the rule. No hidden lines in a section. Also notice all the visible edges. There's a little chamfer up here at the start of the hole, and so there's a visible edge there. There's a groove cut in here, maybe for an oil ring or something, or a snap ring. So there are edges there. And then there are 2 counterbored holes, and they have visible edges. In the next video, we'll go over to AutoCAD and look at some tips for drawing this thing.